Should be recording now.
You turn.
Hmm?
No. I didn't know you turned them on.
Yeah. I always type my password for the user constantly. So.
Yeah.
All right, so we're recording now. So let's go ahead and get out of here, right? So I'm going to do this mostly as scripts, and you should create a list of scripts that you have available so that you can do this. So again, if you were having trouble understanding the concept of which public key, which private key, and all of that, we're going to go over that one last time. This is the last time that we're going to do that to reinforce those concepts, but I'm going to do it for everything. All right, so everything that we cover in the semester, basically, but we don't have to write the algorithm, right? So we're just going to use this library. So it's a little bit more like OpenSSL in Python. Okay, so let's start. So I've created a folder here, if you notice, called PyCrypto Dome. And so I'm going to write my scripts here. So I'm going to start with integrity. Okay, so let's do nano. And then let's call this one integrity. Okay, just some name. Python. So as you saw, everything comes from the library crypto. So I'm going to say from crypto dot hash, and these are the hashing algorithms, of which we have many, right? We're going to import MD5, for instance. Okay, so we have this. So now everything is object oriented here. So we're going to create an MD5 object. So I'm going to do M equal, lowercase, M equal MD5 dot new. Okay, now keep in mind, PyCrypto Dome is an implementation of a lot of the algorithms, right? So it may have some strange things because it's just an implementation. All right, so now if we want to do integrity, we would take string value, let's say, and we want to check the integrity of this. So I'll use as an example, buy the stock at $2,500 a share, right? So let's say that's the message that we want. And then we have a spoofed string value. And that's going to be buy the stock at $1,500 a share. Okay, so the idea with integrity is that if we change one bit, the hash value changes completely, right? So you should know this concept. All right, so let's go ahead and try to do that in PyCrypto Dome. So I'm going to do m.update. That's how it works, right? So we're going to add to the M object, which is an MD5 object, string value, okay, which is the thing we are trying to hash. Okay, so now we can try print M digest dot digest. Okay, and I'm just going to add some parentheses, and we're going to test it out to see if it's working. Make sense? So I'm going to go ahead, Control X, Y, hit Python. Yeah. This. Okay, yeah. So this issue is something that happens sometimes. So in Python, you change basically by adding this B, the string, into a byte array. And the functions seem to be expecting a byte array. Do you guys see that? I added this little B here. So this might be a common issue that we have. So let's try it again. Okay. So I'm running and I'm generating this basically hexadecimal output, right? Which kind of looks like a hash function. Okay, so let's try this again. Let's do print m dot hex digest. Okay, try it. Okay. AB03. Okay. And so that gives us a hexadecimal value. Let's run it twice. So I'm going to go back to the code and I'm going to create another object. I'm going to call it n. Do you guys see that? N equal md5 dot new. Okay. And now let's go ahead and do n dot update string values, same, right? And now let's do here print m. Okay, and down here I'm going to do print n, and then I'm going to do print n dot hex digest, like that. Okay, let's go ahead and run it there. Do they match? They should, right? We can also check. So maybe we can do, let's assign them to variables. So we're going to do m underscore hex. And I'm going to do m dot hex digest. And I'm going to go over here, n underscore hex. And I'm going to do n dot hex digest. Right? And so now I'm going to do a if, or actually I can just do print probably. M hex equal n hex, right? Let's try that. And what do we get? True, right? So what does that mean? They match. So now you have a way of checking your integrity. You can write code nicely in Python with PyCrypto Dome and very easily check for things. Does this make sense, guys? Right, we will of course learn, you already know how to read and write from files. You can just use pickle, or you can, there's other ways, but it's the same, that same knowledge applies here. Okay, so if you wanted to build an application, you could do an if statement. So if m underscore hex equal n underscore hex, right? And then do something like 1, 2, 3, 4. You would do print pass else 1, 2, 3, 4 print does not. Got it? So in this case, hopefully we'll get pass. So I'm going to control X, Y. And it passes. Okay. Now we're going to explore we're going to use the spoof value. I'm going to go ahead to the spoof value. And that's going to be n, right? So I'm just going to do spoofed string value. So I've changed one number, which is from 2,500 to 1,500. So I'm going to comment this out actually, so we don't use that. All right, and we're just going to focus on the hex digest as we have done in other frameworks. And we can proceed. Control X. Hit clear. Yeah. Oh, this is the same thing, right? Same error. At the B, it's a Python thing, right? To change the data type. Okay, let's go ahead. What do you think? So now, even though we changed one number, the two hex values are completely different. We've changed the integrity of this. We can see that they're not the same, so they're false. And basically, you can build your application that says does not pass. That's a very simple example of how to use PyCrypto Dome for integrity. Any questions? Everyone with me? Okay. We built that one. Now we're going to explore doing encryptions with symmetric encryption, right? So symmetric encryption are the block ciphers such as AES and DES, but we're not going to have to implement the algorithm like the for loops and breaking into blocks. Instead, we're just going to invoke our library. So let's see here. Okay, so let's try. So what are the symmetric encryption algorithms that we have available? Symmetric encryption or block ciphers? What are they? Those are the modes of operation. So remember, there's 4 modes of operation, and then there's the symmetric encryption algorithms. What were they?
AES.
AES and DES, exactly. And AES would be the one that's currently available, whereas DES is the one that has been broken. Okay, we have both of those in PyCrypto, so you can just do AES and build your applications that way. So let's go ahead and try. We're going to try both of them. Okay, so we can create another script. Okay, so I'm going to do nano here. And let's do can call this block cipher. .py. Okay, so we're gonna do the same. Let's try from crypto cipher dot cipher import des. So the data encryption standard. Okay. Now we're going to initialize a des object. Okay. Des object. And we're going to say des dot new. And now we need to provide this with a key. And because this is an implementation, I believe the minimum is 8 characters for a key, and it may be multiples of 8. Again, because this is how the implementation is, okay? So I'm gonna do this. A, B, C, D, E, F, G. Now, I'm giving you this right now as a hint. On the practical exam, this may be the thing. It's a key, right? And it's a symmetric key. And you remember that what I wanted to do was hide that key. So I may have hidden that key. I may have encrypted it with RSA. So on the practical exam, what you may need to do is you may need to find a cipher, right, that was generated with RSA and factorize the prime numbers, break that cipher, and then you would get something, a key that goes here. Does that make sense? So I'm telling you that right now as a hint. Okay, write it down. Okay, because that's kind of how the game works. And I'll use some of these scripts for the practical. I'll mix them up, all of them. So if you remember, the RSA one is where you can factorize the prime numbers, right? And then use that code in RSA, as we did in an example, to calculate the P and the Q, and then get the D, and then be able to get a key. And then that key would possibly go here. Okay? Questions? All right. Anyway, so this would be like a key, A, B, C, D, E, F, G. And then we need to specify, comma, the mode of operation. So remember, the mode of operation is ECB, CBC. You should know, for instance, what ECB is insecure. That's where we could see the triangles, but the algorithm is des. So it should be something like des dot mode. And here I'm gonna use ECB. Okay. So let's run this just to see if we get any errors. Incorrect des key, length 7 bytes. Did I miss a letter? A, B, C, D, E, F, G. I think it's I only had 7 letters in there. So this is what I was saying. I know it's that can be an issue. Oh, the bytes. Yeah, it wants it to be a byte. Right, so whenever you encounter that error, PyCrypto Dome just really does not like strings. All right, so you want to convert this to a byte array. And I'll show you other ways of doing it. So this basically, currently we've created a des object with a mode ECB, okay? So now we're going to try to encrypt something. As you are probably seeing, this is very easy and straightforward. So now, what is des for? Which one of the principles? Integrity, authentication, confidentiality. Usually it's for confidentiality, right? That's what we're trying to achieve. So we're going to encrypt some message. So let's do plain message, okay? And I'm going to say, probably we're going to need that B again, right? And then we're going to say the chair is on the table. Okay, something like that. All right, now this one here also may need to be a multiple, or we're gonna have to do padding, okay? So let's try it out. So what I usually do is I like to do print of the length of plane to see if I can't figure out if I need padding, okay? And that's just because PyCrypto Dome is not going to help you with that. So it leaves it to you to do. 25, okay? So that doesn't sound like a multiple of anything. We got to think about what the multiple might be, but let's go ahead and try to encrypt and see what happens. So I'm going to do, I already created the des object. So I can say des, yeah, I'm going to do cipher equal des object dot encrypt. And what are we going to encrypt? We're going to encrypt the message. Might be a good idea to create something called padding, which you guys are very familiar with. And then let's just make a padding that's empty currently. And then that way we can just go ahead and let's put the B in there just in case. All right. And now we're going to encrypt this object. So we can say something like plain plus padding. Okay. And then let's try and print it. And let's look. I think it'll give us an error, but let's see what the error says. Yeah, data must be aligned to block boundary. So what would you guys suggest we try here? Multiples of 8, right? And the size was, I think, 25. So what would be a multiple of 8 there? 24, but that's less. 32. So how many? How many would that be? 25. 7, right? Let's try X as just 1, 2, 3, 4, 5, 6, 7, right? Let's go ahead and try it again. Okay. Got it? So it took it this time. So like I said, why doesn't it do the padding? Because it's, it leaves it to you to do. So now that we've encrypted it, let's try and decrypt it. When I go back to Nano, we're going to use the same object. So now we're going to say decrypted plain going to be equal to des object dot decrypt, and it should take cipher. Okay, so then we want to encrypt this. Or print it, sorry. So I'm going to do print decrypted plain. All right, so please go ahead and try that one. The chair is on the table and it gives us back the padding. Okay. All right, any questions? So that's a simple example. We could have also created, because the key is something that you're going to move around, right? It's a thing that we would have to share. We know the key is this A, B, C, D, E, F, G. We know how to save that with pickle dump, right? So what I would recommend is having this in a variable and then saving it with pickle dump, loading it with pickle load. But we can create another object with the same key and it should give us pretty much the same. So let's say, other decrypted plain, and we're going to say other, actually we're going to need this before, other des object, and we're going to assign to a des dot new. And once again, so we would just plug in, assuming this is Alice and Bob, so they've shared the key securely. So now you can do A, B, C, D, E, F, G, H. The single quote, and the mode of operation needs to be the same one. So you can do des.mode ECB. Okay. So now that we've created this new object, we should be able to decrypt. So I'm going to do other other des object dot decrypt cipher. Okay, so we're going to print other decrypted plain. We're going to print this out. There you go. And as you can see, that's basically how you would do it. As you can see, it's very easy, right? So PyCrypto Dome is really nice, very easy to use. Any questions on any of this so far? No questions? Okay. All right, so we've done symmetric encryption. We've done integrity. Let's see what else we should do. All right, so let's do AES. Let's try AES. So we've got, let's look at the scripts, ls-l. So now I'm going to do nano AES cipher .py. It's going to be very similar to the DES example, obviously, because they're similar. But as you know, AES is more secure, so you would probably want to use AES for your applications, right? So I'm going to do from crypto.cipher import AES, okay? So we're going to need a sentence. Let's say data plain, use lowercase, data underscore plain at the B. Okay, so the dog is barking at the cat, and something like that. And so that's going to be our input. And then we are going to create the object, the AES object. Let's say AES underscore object. Okay, and we can do AES dot new, oops, lowercase, dot new. And now I'm going to create a key in a different way. So keep in mind, it could be like ABCD on the practical, but you can also generate a key. I could do that. So let's call it secret key. And I'm going to need a function that generates a random sequence of bits. So I'm going to use from crypto dot random import get random bytes. So hopefully this function should be very useful to generate a sequence of bytes. Now, as you know, these are not actually random numbers, but pseudo-random because it's a computer. So let's now use it. So I'm going to use get random bytes. And this function takes as input a size. So in this case, now I'm going to make this a little bit bigger at 16 instead of 8. Got it? AES you would want bigger keys. Sorry. Okay. So we're going to do AES new. And it takes the secret key. Comma. And then what else do we need to put in here? We put in the mode of operation. So there's a mode of operation in AES dot mode underscore EAX. So as you can see, there are actually more modes of operations for the algorithms that become a little bit more sophisticated. Okay, so you can just use this one. So on the practical exam, these all may be parameters that are hidden and you have to kind of break, okay, figure out. Although I do provide a lot of hints. Okay, any questions? Pretty easy, right? But this is AES. So now let's go ahead and try to encrypt something. Oh, this is a nice function. This one actually should provide the cipher. So cipher AES has a mechanism like this. Provides two values. Cipher text, comma, and what is called a tag. Okay, so it's basically an encryption in a digest. So that's that's basically a hash, correct? And so we can do AES underscore object dot encrypt and digest. And what do we encrypt and digest? Data plane. Okay. Questions? Everyone with me? So let's go ahead and print these two values now, see what they look like. So I'm going to print ciphertext. And I'm going to print tag. I'm going to print a line in between. Okay, so let's go ahead and try that. Oh, this is, yeah, sorry, that's the wrong one. So it should be AES cipher. Okay. And so we've got, this is the tag, right? And this is the encryption. Got it? Questions? All right. So now what would you want to do with this? You want to send this to your partner, as one of the problems will require you to do. So we are going to write this out to a file. Okay. So how do we do that? Let's go back into Nano. Okay, so you can do file out. Open, and I'm going to create the file name. So in this case, it's an AES, right? AES cipher AES cipher, yeah. .bin, just like OpenSSL would do. And we need to specify that we want to write. So we're going to say WB. So basically write bytes. Okay, very similar to Pickle. And now we can do file underscore out dot write. And what do we write? We're going to write ciphertext. Questions on this? Remember, whenever you open a file, you want to close it. So we're going to do file out dot close. Okay. So I think that's all of it. And notice I'm ignoring the tag right now, but you may, we may consider this later. Okay, so let's go ahead and do that. Okay. So we have now a cipher.bin. If we cat AES cipher .bin, we have an encrypted message. Got it? So this is the message that you can send to your partner. So Bob, let's say Bob wrote this. So Bob now has this, and it's going to send it to Alice. Okay, Alice receives it. And what is Alice going to need to do? She's going to need to decrypt. The trick is we need the secret key also, right? We need to send the secret key. Let's think about that. Yeah, so we're gonna have to create that key. For now, I'm going to not encrypt that file, just write it out. Okay. I'm gonna go here. And let's do file key. File key open. AES key dot txt. Okay. Comma. WB. And now we're going to say file key dot write. And we're going to send the secret key. Okay. So remember that this is the key that we generated. So we're going to need, and we're going to encrypt with it. So we're going to need to decrypt with it. So we need to write it out to a file. secret key basically, and then close. So file key dot close. All right, so that should be all we need to do. Actually, there's one more problem, right? The initialization vector or the IV. So we also need to think about that one. Okay. So let's just try this for now. Okay, so let's go ahead and run it. Do Python AES cipher file. Oh, I would type on. Okay, it worked. So now I'm going to do ls-l. You can see now I have the AES key. I can cat this one. AES key. And you can see it's basically a byte stream as well. All right, so obviously we would send this. Now we can't send this file like this because it's not encrypted, right? So that would be insecure if we did that. So what do we need to send this key? RSA, and that's where the public and the private key comes in. So we're not going to cover that today. We're going to cover public and private key on Thursday. Okay, but basically I'm just bringing everything together and I'm just showing you today how PyCrypto Dome works. All right, so now let's look at loading these files in the decrypt algorithm. So assuming that we've sent the cipher, and for now we're going to send the key in plain text just to keep it easier. Okay. So let's do decrypt. AES decrypt. Right, so nano AES decrypt.py. And what do we need? We need to, from crypto cipher, from crypto.cipher, import AES file in open AES encrypted.bin, right? So this is the AES encrypted, .bin. Was it cipher or encrypted? Can't remember. AES cipher. Cipher.bin, comma, RB. So we're going to read bytes. And then we can do So we are reading the cipher text. So it should be cipher text file in dot read. Right? It's the cipher. We're bringing it in to the program. And then we can do file in dot close. Okay, the next step would be to bring in the key, which is unencrypted currently. And this will be, like I said, this is the problem that you guys will have to solve, right? So you're going to have to do everything: integrity, confidentiality, authentication, with these scripts. Okay, so that's kind of the idea. All right, so let's do file key. Open AES key, which we would save .txt. Let's see if that's the right name. Yeah, AES key. Comma RB. Then we say secret key. And we're going to read it in. So file key dot read. Okay. And then just close the file. These are called filed handlers, by the way. So file key dot close. Okay. And that should be it. Now we can just invoke the AES object. So we're going to do cipher AES dot new. This takes in the secret key, which we do have. What was the mode of operation? We need to put that in there. So AES dot mode. I think it was A. What was it? Was nope. Let's cipher. Okay. EAX. Okay. So you have to match this one, EAX. Like that. Got it? So we've got the secret key, we've got the mode of operation. And then the idea would be to do decrypted message equal, message, and we're going to invoke cipher AES dot decrypt. And this should be ciphertext. So in general, this is the approach, right? So you have the key, you bring it in, you have the message, you bring it in, and we try to decrypt it. The only thing I'm kind of not sure about is the initialization vector, right? So if this has an initialization vector, we're going to have to use that. So we need to change it a little bit. So we'll tweak it. Okay, so I was changing the code a little bit here just to try it. All right, so let's see if we can print a decrypted message. If not, huh? All this time or just now?
Just now. Just now.
I don't know why it doesn't. There we go. Thank you. All right, so let's try printing it. See if it works. If not, we'll extract the IV. So decrypted message. Okay. Clear. Run it. So I don't think it decrypted it, right? So that's what I would believe. So decrypted message. So it needs the initialization vector basically. All right, so then let's modify it for that, okay? So to be able to modify it for that, we need to go back to the encrypt. Let's go back to AES encrypt. Yeah. Let's, yeah, so I'm also going to copy this because I gave it a string, an AES cipher.py, and I'm going to change it to, or create a new copy called AES encrypt.py. Okay, so that's all I'm doing. Okay, now let's go into that one. AES encrypt.py. All right, so let's look this over. So cipher, get random, got some data, secret key of 16 bytes. I'm gonna add a line here. Okay. Then we save the key down here. That should be correct. Then I'm gonna go here. I'm gonna make a tweak here just because I know this example will work. So I'm gonna change the mode of operation to the more familiar CBC, okay, which you guys may remember. And then the rest should be. Oh, and instead of doing, I guess I have this encrypt and digest. We're just gonna do encrypt. I'm gonna modify it a little bit. Encrypt, and then I have data, and that creates cipher. Okay, so the question is, how do we save the initialization vector? So it's actually not too difficult. I'm gonna open AES encrypt bin or cipher bin. And I'm gonna do the following. File out dot write AES object dot IV. Okay, so the IV is about 16 bytes, just like the size of the key. Therefore, the first 16 bytes in this file are the initialization vector. The rest should be the cipher. Does that make sense? Okay, so then we can just write, that's basically all we have to do. Got it? Do you see how convenient that is? Right, so we're, basically the first 16 bytes are the IV, and then we just plug it in the same file. Okay, so if I look at this, it looks correct. So now let's go ahead and try it again. I'll do this print done just to make sure that. Okay, it does it. So Control X, Y, hit clear. Yeah, I've never Python. Data must be padded to 16-byte boundary in CBC. Okay, so then the padding, right? So help me out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So what do you think? 32? So it's 29, right? It would be 3 spaces. 1, 2, 3. Yeah. And huh, sorry?
You said 33 there.
Well, it's 16, so I assume it's a multiple of 16, so 32.
Oh.
Right? And I had 29, I think, so I added 3 spaces. I already showed you another way of adding the padding as well, so you can try it different ways. I just want this to run. Okay, so try it again. Too many values expected to. Oh, yeah. This is because I was doing the other thing. So just get rid of the tag. Right? Try it one more time. And now there's no tag anymore. Right? Tag. Okay, perfect. All right, so we've got the file. We're almost done, okay? So let's just now do the decrypt and we'll end there today and pick this up next week. Or sorry, not next week, on Thursday with RSA and finish it up, digital signatures and so on. And then I'll assign a set of problems that, remember, you will have to demo, all right? So I it'll be a few new problems. Okay, so AES cipher.bin should be the file. So now we need to go to AES decrypt. Nano AES decrypt, okay? So let's finish this one up. Okay. All right, so we've got file in, open AES encrypted bin, right? Or AES cipher bin. We read it in. Now here we need to read. So we're going to say file in read 16. So basically it means that it's going to read the first 16 bytes, if you will. So that means this is not the cipher text, but instead is what? The IV, correct? All right. And then we need to read the rest. So we're going to say cipher text equal file in dot read to read in the rest of the information. Okay, so that was really hopefully the only thing we needed to do. Then we close file in. We also open the key. That should be correct. So nothing there should be a problem. And then finally, we are ready to decrypt. So we're going to say AES.new secret key. AES should be what? Mode should be CBC. Very good. And now we need to provide the IV, which we do have. See how easy that is? All right. And then hopefully if everything works, we can do cipher AES decrypt of cipher text, which is what we have here. And we're going to print decrypted message. Cross your fingers, right, that it works. Decrypt. Yeah, it works. That's it. And you've got AES now, and you know how to save the files, know how to save the IV, know how to save the keys. So we've achieved integrity and confidentiality today, but the secret key was exchanged in plain text, right? And that's still not complete. So on Thursday, we are going to exchange the key securely with RSA, as you know, and we're going to get back into the whole public and private key of Bob and Alice. And we also need to do the digital signature. So we're going to do authentication. Okay. So I'll do that on Thursday. And then, as I said, I'll assign some problems. And yeah, that's it. All right, guys. So we're going to stop here for today.